Oh, it looks okay. Good. It looks like Jesse's got his presentation up there. Okay, so welcome to the meeting. Thanks for attending, and Jesse is going to present his paper that he selected a while back, but he's got the slides done, and he's kind of gone through. He's been actually meeting with another one of my collaborators on a different project. He's going to tell us today about this paper that unifies cybernetics and the Braitenberg Vehicles paradigm. And then we'll talk about some other things in the meeting. Ziyi's got some stuff he wants to talk about. We'll talk about Ankit's presentation, and then we'll talk about Stefan's use cases. So let's start with Jesse.
Hey everybody, can you hear me okay?
Yeah.
Yeah.
Okay.
Yeah.
Good morning, good afternoon, or good night, wherever you are. I'm presenting this paper. It's called Neurodynamics in the Sensory Motor Loop, representing behavior with relevant external situations. And I'll start off by saying the paper itself, well, here's a bit of an overview. I'm going to go over the paper a little bit, discuss its key concepts, and at the end I'll tie it into the projects that we're working on or I'm working on, and then the questions. Although I might kind of combine the relevance and the questions into one thing because they overlap quite a bit. But just to kind of note the paper, if you haven't read it, it's very formal. It's not, there aren't experiments, there aren't data from a method. It's just kind of a conceptual paper, which is interesting, but also challenging for me because I'm not that familiar with dynamical systems or like the formal logic behind them, or talking about networks. So I'm kind of just going to keep this presentation to discussing the concepts in general. And as you guys are probably aware of embodied cognition, that's sort of the foundation for this. And the key idea behind this paper is looking at these, stemming back from like von Force, or these entities which classify objects and situations in the physical world. And obviously the big theme here is the sensory motor loop of an actor engaging with the environment, getting feedback from its sensory inputs, and that affecting internal, its general internal workings or its cognitive system, and then that leads to a change, perhaps in behavior, and then new sensory inputs come in, and that's how it goes. And so this paper looks at how the formation of these structures are formed, or at least could be formed. The assumption is the organism must be able to relate discrete internal structures to relevant aspects of its own interactions with the environment. And kind of expanding upon that, the sensory motor process itself is kind of a continuous engagement with the external world, but the quote-unquote internal entities must be discrete enough to be able to reference specific external environmental cues or references, and then be able to have discrete internal forms of structures that help identify what those external things are, relate to them in unique ways. So it must be both stable and unstable, which is interesting because within a certain time domain, you have to have a stable way of interpreting the stimuli that you're getting, but it also has to be flexible and unstable enough to change when those references also change. So this kind of, if there's a sensory motor or like cognitive variation in how things are being interpreted or processed, the system itself must also be able to kind of change in order to be, adaptive and lifelike and be able to survive. And in the paper, very similar to what we use for a Braitenberg vehicle, it talks about a quote Animat, which is a simulated or physical robot with a body, quote unquote, sensors and actuators, and then a neural network for behavioral control, essentially. And again, the sensory motor loop is core to all this, and yeah, I've basically already said that, and it kind of alludes to, okay, it's kind of a recurrent neural network. This is something that they said directly in the paper. The basic concern here in the paper, one of them is to specify the role of, for example, attractors, the basins of attraction, transients, bifurcations, and stability properties in the context of a system acting in a sensory motor loop with 2 A's. One shouldn't be there. So the concept of time discrete neurodynamics, or things that happen in set time blocks or time situations, they say it's transferable to other systems, kind of obviously. And then some of the interesting implications of the paper are about memory, and I'm going to kind of defer to other people or professor here, in that I'm not that familiar with hot field or associative memory, or kind of what they're getting at with their blurred memory kind of part of the conclusion. But they seem to be offering this as a alternative, a more flexible way to have memory, or to look at memory. So we'll get into that when we get there, I guess. So under the major key concepts in the paper, the first is parametric stability, and it basically has to do with the fact that it has to do with, if you look at the I guess the second major bullet indent here, certain behavior is robust against noise and can be classified as the same, although initializing sensor inputs vary over a larger domain. So it's kind of like if the entire system always changed when the external environment gave a slightly different sensory input, that would be very unstable. And it's kind of parametric stability, from what I'm getting in there and how they're talking about it, is how do we kind of group enough of these inputs within a range that there's an acceptable or worthwhile behavior that you can operate. You know, like if it's an example might be, you know, if it's really hot outside, it's acceptable to wear like shorts or short sleeve stuff. But you know, if it changes 1 or 2 degrees, you maybe not are going to change what you're wearing. But when it gets really cold, you put on more layers. Very simplified in that sense. Bifurcation is kind of getting at the differences here, like when you're actually changing the references. And eventually you'll have enough, you know, an actor or an agent would have to experience things and get enough that they will have to change their parametric stability and go into another state. Like if it's too cold out, okay, then you're changing your behavior somewhat. And I have an extra slide here with no real changes. Okay. Transient versus metatransient. This is something that I'm not quite sure how to talk about, because I'm not quite sure what to say a transient is, other than I looked up kind of a generic definition, and it's sort of how long the trajectory to reach the attractor, or how long it spends in a transient phase. Would anyone like to offer a better explanation of that?
I think transient, when they say transient, so they're thinking about this in a phase space. You know, I don't know, the best way to describe that is like maybe like a fitness landscape, or a space where you have a ball or a point that visits potentially every location in that space. And then, you know, the attractors are the things where that point sort of sticks around that general area. If you think about strange attractors, those are things that have like you know, where the point orbits some point that isn't really defined as anything, but it's sort of like that's where the point spends most of its time. So
Yeah.
then what they're trying to do, I think, is they're trying to figure out what the states are. And that's the interesting thing, because a transient then is like, it'll transit to a place, and then it'll spend time there, and that's the state, and then you can characterize that in different ways. And so it's a little bit difficult to sort of define it very precisely, but that's what they're trying to do.
Okay. So, like, in the concept of a classic Braitenberg vehicle, the transient would be its process to, like, if it was attracted to light, it would be its process of going towards the light. Or
Yeah, except it's a little bit more abstract than that. Like,
yeah,
it's all the things that go into making that happen. Like,
right.
yeah.
Okay. And then when they're talking about metatransients, is that kind of like all the things that go into that, like you said, or
Yeah, I
did you
think
have?
that, like, so, I mean, if you can think of a Braitenberg vehicle, if you took, like, about 10 different things that you could measure, and then put it into, like, some sort of principal component analysis, where you got, like, an eigenvector, uh, or, something where that would be sort of the metatransient. But again, I don't think, that they're using this very loosely because, it's just conceptual. They don't have, like, they don't define the
Right.
actual method they're using.
Yeah. So again, it's all very, very conceptual, but it's interesting to think about because these are things that I probably should have stated my own personal motivation for this paper, and maybe he'll do that more at the end than here. But just to allude to it, I've been very interested in stuff like this for a long time. But part of why this paper was so curious is because I don't know how to refer to much of these things. So this is at least giving me a starting point, and I have a lot to learn from their references. But there's a lot of interesting stuff here. One thing they do say about metatransients is that part of the interesting deal with them is mapping them, is trying to figure out how to map them towards the eventual actual behavior component. You can't really do it, but you kind of map, as they're saying, the projection. And they're basically, one of the things more concrete things they take away from dealing with this is that not all elements of the neural system will be directly involved in the generation of motor signals, or in the case of the Animat itself, not everything going on will directly affect the behavior or the movement of the Animat. And so they break it down into internal neurodynamics, which have no direct effect on the behavior, and the effective or horizontal neurodynamics, which do have a lead to movement or change in the behavior of the Animat. And then kind of their third major concept is the dynamical form. And essentially it's classes of parametrized dynamical systems. Like groups of, like, I'm getting it as like a form would essentially be having a set classes of these parametric stability groups. But as they say in this paragraph, kind of summarizing a lot of their concepts at the end in the discussion, was taking our argument for metatransients is serious, it becomes obvious that a dynamical form associated with certain types of behavior is a reasonable representative for behavior relevant situations in the external world. Thus, taking parametric stability as essential for the reproducible identification of the same situations gives a reasonable conceptual basis for treating brain dynamics induced by an ever-changing environment. So I kind of see this as they're coming up with forms as a way to group behaviors, and this and the concept of parametric stability are kind of offering some terminology or ways to look at, okay, how does an organism not, why doesn't an organism just willy-nilly change at every moment? Like, what are the sort of stabilizing factors of behaviors, and what to what end does that stability bifurcate or change in the sense of, okay, now we're outside of the zone of stability, so the behavior is going to change because enough has changed. Agenda again. Just a little commentary on the relevance. You can probably see some overlaps already in general Braitenberg stuff. I wanted to specifically note hysteresis, if that's how you say it, in that it's kind of a thermostat-ish example, very simply, and it has to do with they say demonstrating development of a system crucially depends on the history of the system, and it's kind of depending on which way the changes are coming, that will affect the related actions and related behaviors. And as I'm going to get to in the next part of the discussion, they seem to draw some interesting conclusions to memory in this sense. But I find hysteresis a very interesting concept in terms of cybernetics and regulation. So I'll kind of leave it at that. And specifically in regard to having a regulator theorem, I can see it here as well. I'll just say it's very interesting in that it touches upon some of the sort of, for lack of better terms, infrastructure engineering of how would a good regulator be skilled at it? How would it be accurate? Like, there has to be some mechanism for having essentially accuracy in what's making a regulator good or functional. It has to be able to have an appropriate amount of adaptability within sensory motor life, and then its own cognitive processes and representation. So something that's trying to model an environment probably will have to have at least somewhat similar conceptual quote-unquote entities, going back to the first slide, or something like form, something like an ability to differentiate and sort of tag or demarcate, okay, within this realm of sensory motor inputs, this is an acceptable or a rewarding behavior. But as that changes, I also need to change. But so that's what I think is there. And going to general questions and discussions, I have a bunch of questions that I've already steeped into the presentation so far. But one that I would generally just ask specifically is, there's talk in the paper about slow inputs in the system, and then given slow inputs, which is kind of, I'm interpreting that as inputs that are consistent and not too rapidly changing. But I guess would anyone care to say what slow inputs means in this context, if they have an idea of it relative to other kinds of faster inputs?
I think you basically have it. I don't know actually, but
okay.
Yeah, I mean, I think I think the point is, like, they're talking about these kind of inputs versus maybe like feedback as well. So like, if you have a slow input that's like something that the system can integrate pretty easily, a slow input isn't going to change a lot over periods of time. So it kind of, you think about like if you're like I don't know, doing some sensory motor task, and the floor doesn't change really very much, and you're walking along it, you don't have to pay attention to the floor. But if you go up a set of stairs, then you have to pay attention constantly to the floor, because you have to like make sure that you hit every step. And so that's maybe a faster input. But you get feedback, so you can use feedback and a slow input to sort of, as stand-in for the actual input. If that makes sense.
Yeah. And they do note in the paper, they note that I forgot the proper term, proprioception, but basically awareness of the body. So it's kind of is in line with that example. Like that's something that is between that and the concept of noise. It's kind of having. I kind of see it as like like in the short term, is there enough of a consistent signal there that it kind of can functionally be processed? And I think they discuss the meta-transients as a way to deal with when it isn't slow also. I think that's kind of why they put meta-transients. They saw meta-transients as a necessary way to deal with that. As in, and I think in that context, meta-transients might be sort of these over. This is actually part of the paper that I wasn't quite sure what to make of it, but they say something like, as usual, higher centers are assumed to check the adequacy of activities along sensory motor pathways that are modulating the sensory motor flow of signals. And I believe this is related to why meta-transients are important in what they're saying, but I'm still wrapping my head around that, as they say.
I think the assumption there is that so the brain has the motor centers in the brain. Basically, people think that a lot of the inputs come into, say, the spinal cord and to the midbrain, and there's a lot of like pacemaking and automatic activity there. So you get these things that like kind of regulate movement. But then you have higher order centers, maybe like in cortex in humans, where those inputs get processed more. So if you think about like playing a violin, it requires a lot of fine motor control, and so. But you can't just do that using like a simple, feedback mechanism in the spinal cord. You need to have higher order processing, and so it actually this is actually pertains to a lot of robots that walk. I don't know if you've seen the Boston Dynamics videos online, but they do they have the dog, and then they have the other four-legged animals that. They they can actually build them to do a pretty good job of walking, and along difficult terrain or whatever, upstairs, and they are able to use sort of a brute force feedback mechanism there. But in the brain, perhaps you need more. You need something that's a lot more sort of complicated. More complicated way to achieve those sorts of things through feedback. So that's what they mean, I think, by higher order centers in the brain, is that they're like areas where it gets processed and maybe merged with other sensory inputs.
Okay. That'd be really interesting. That makes you think about the old octopus stuff and their distributed nervous system, because I guess their limbs operate very distributed, and then they have a lot of overriding. So yeah, going to the memory and learning component again, I'll just read. Part of my interest in this stuff is that it kind of there's sort of an interesting necessity of sensory motor interaction in order to create context, because only through this is more of me saying this than what's in the paper, clearly, but only through certain interactions can you gain sort of a context or a space within which you can model or reference certain things. So it's like creating a space within which understanding can take place. That's kind of a broader philosophical look at things, I suppose. And then what they say in the paper here is the possible role introduced concepts, being what this is in the paper. The possible role that you talk about can of things they talked about, excuse me, can play for understanding neural representations of behavior relevant situations in the external world, and correspondingly for a notion of memory which is based on specific attractors, like for misspelled, for instance, fixed point attractors of multiple networks. Yeah, that paragraph, maybe I shouldn't have chosen that one quite like that, but essentially at the end of the paper, they're comparing things to hot networks and saying, hey, this might be a little bit more flexible. And I'm curious again if anyone has any commentary on differences they see between, you know, this paper and hot field networks, hot field associated memory. Any comments? Because I'm not quite sure.
Well, I mean, you know, I think it's an interesting point. Like the comparison between like a dynamical system and then a network. It's like the discrete representation, and then you have more like dynamical one, which is more continuous. But I mean, we can talk about that more, and you know, as people get ideas. This is it's a very good presentation. Thank you, Jesse.
Oh yeah, sorry, it's a bit longer than I expected.
That's fine.
And I got
but I think, yeah, this is a lot of stuff that we could think about, and I think it's relevant to a number of people's presentations, and especially, you know, some of these issues about, like, you know, thinking beyond networks for a minute and saying, you know, what is it about what are the networks actually producing, you know, and getting that. I mean, we see it in the vehicles and their behavior. But, you know, to actually classify the behavior as like the output of these networks, you know, what is it that they're doing? Are they like tending towards certain things? Because I think in this case, you know, they talk about states, and we're used to thinking about states as these discrete things that we can easily classify. But in this case, it's not that easy. It's like their tendencies, and then, you know, you have to figure out what the tendencies, you know, how they group together, what they mean. So it's a little bit different way of thinking about it, but I think it's worth thinking about.
Yeah, I definitely agree, and that's kind of why it's kind of like almost like this is a very crude analogy for like sort of activation energy and what it takes to get to a specific state, and what other factors are there in sort of anchoring or a state or a you know, either internally or externally, like either an external resource or an internal, you know, cognitive mechanism that would want to prolong a state. It's all very interesting stuff. So, yeah, thanks guys for paying attention to the presentation and staying with me through it, and get back to our regularly scheduled programming.
Okay. Yeah, I mean, there's some actually this comes out of the literature on like dynamical brain science, dynamical neuroscience. So we can actually, I can put a couple of papers on that area in the Slack channel. There are a number of people doing work in that area, so we might find it interesting if I distribute some of those resources. So, all right, thank you. So next up, I think we have. Well, let's. Who wants to go first? Do you want to go, Stefan? Do you want to talk about your use cases?
I would just relog in because I'm apparently at somebody else's profile now.
Okay.
We exit and enter once again. Right?
Okay.
I was wondering who that was. That's right.
Oh yeah. There he is. Okay, you're in.
Yeah, I can talk a little bit about my project. Maybe we will lift the main discussion to the email or maybe Slack conversation if you want it to be public. I would just tell like how things are now and what I'm currently doing.
Okay.
So basically, yeah, basically this week I've been mostly doing things concerning rendering and world physics. I've discovered several bugs that were connected to how vehicles move and how the movement is calculated. So basically, these bugs that I've discovered, they've allowed me to fix this main bug of vehicles kind of leaving the actual simulation environment. So, like going to the wall, so to say.
Oh, so the boundary conditions.
Exactly. So I've solved this bug now. You can see it in the weekly public pull request. I mean, yeah, I've also been working a little bit on code structure, on like several other things, and I'm gonna say there are of course some technical things to fix there as well. Apart from the use case that we are talking about, apart from all this stuff. I also consider the main points to be first fixing the technical issues, should there be any. So, for instance, I'm also planning to improve, the fitness function, like how we've bespoken it to be, so that we calculate like the area under the polygon. It's also is to be done yet, although it may be pretty. It's pretty fast job, I guess. I reckon. And there are also some other bunch of stuffs that need to be done. Yeah. So yeah, so main things now are, it's all about bug fixing, probably maybe adding some more simple technical features, writing documentation. So I still have to do write a notebook with the documentation if you still want it. Of course, I'm documenting in code, but some general comments you can't quite fit in the in-code documentation. Yeah. So I would write a notebook there, and also then will come the use case. So basically, it would be like the fourth number on the list, where I would just, as I imagine it, I would just add some more definite features. So some features for a concrete use case, for an exact use case. I would add just some bunch of features that would allow us to, launch this experiment and kind of go through it. Right. That's how I imagine it, and that's what I'm going to do basically, and that's what I've been doing. Like last week, the week before that, I was doing some plots. I was testing the code. Yeah, I converted real-time histogram. I did work on the data export that you told me also to do. Yeah, there were some strange values in Xchart in this plotting engine, and I've also done my research on that.
Okay. Yeah. Now, about our discussion about use cases. So you thought that was doable. What we were talking about was something you could implement. So, I mean, the idea, as I understood it, was that you thought, well, okay, we can do specific experiments in specific domains, and then we'd maybe have one or two of those to offer people if they want to, like, just open it up and run it without having to configure it in any way.
That would be very great to offer even maybe several good and several popular experiments in that. Of course, I would say I would wish to have for sure, and it would be pretty nice. Just the point is, we should also, in my opinion, consider the time that we have yet.
Yeah, we don't want to get too far down that hole. I think what you mentioned though about like a lot of the fixes is going to be, I would maybe try to implement one popular experiment, or just, like I said, if it's like spatial cognition, it's like a basic, maybe like a demo or something, and then that would be enough. for the submission. So I wouldn't spend a lot of time on that. I was just kind of giving ideas as to how we might approach it.
Sure. So basically, I've just also my suggestion was based on that we kind of show the people some things they can relate to in our simulation. So basically, what I've meant by this use case is more like also some demo, some prototype, maybe even. So that could be some maybe some scientific mistakes or small misunderstandings, even that we don't want to clean or polish. But just show the general principles so that the people can relate to that, so they can, maybe they have some ideas in their head, that they also maybe remember our simulation after they out of the conference. Kind of like more a prototype thing, I would say. Basically to show all of the whole community what we are doing in the lab, what we are doing with this project, what our thought is.
Maybe I think that's something that I think maybe just the way to approach that is just to have one simple example, and then like after the end of the project and after the end of GSOC, we can think more broadly about how to like incorporate them. Because I mean, like if you look at any platform like a agent-based simulation platform, or even like the brain sim that you're working with. I mean, those have been developed over time. Like people have like implemented, like say, well, let's take like the Morris water maze. You might implement something like that, but it would take a bit of time for people to maybe validate it. So, I mean, I think the better approach there is just to make like something that's like a very simple demo, where you're just showing like how you might set it up. And then
sure. And then then maybe even after this conference is over, we would also have some valuable feedback from the community about what they actually want to see from this simulation suite, right? What they're interested in as cognitive scientists, as behavioral scientists, what they really want to see in this program, what they don't want to see, or maybe what they're indifferent about. That was also my thought, and then we can kind of base our future project plan concerning this simulation on this feedback which we receive from INCF assembly. So I mean, I'm kind of into doing the demo now.
Okay. And then I sent you that email about the travel grant. So they're trying to figure out how to distribute that. So what I need from you is like a justification. So I gave you, I forwarded you that email from Malin, and she just
I've seen that.
Yeah.
I'm thinking about what to write the best so that it's convincing for the Malin.
Okay, and then I'll send it to me, and then I'll send that to her along with another. I have to like tell her why I think it would be.
Yeah, will do.
Okay, that sounds good. Anything else?
Not on my side, no.
Okay.
I think I'm over.
About Ziyi, you had some updates for us.
Yes, so firstly, just like a suggestion for Stefan. So you mentioned about special values. I also had that problem in the last 2 weeks, and I did numerical analysis and found out that was due to the accuracy and stability of algorithm. Maybe you can check that.
I'm sorry, can you repeat what was it's about?
Yeah, I also had a problem of special values. So I think you mentioned that before.
Special values, like where?
Yeah. Sorry, did you mention that?
Special values, or
for your data.
Like you mean like spatial, like in sense of doing something with the space, or what?
No.
Yeah, I think.
I heard you talk about that you have some strange values that you may need to check.
Yeah, sure, but like I mean, they were mostly connected to the rendering engine, how it turns out. So it was still this good old Java FX issues that like were just connected to the framework. Yeah.
Sorry.
No, it's fine. Yeah. Did you have like any special values problems with the data itself? Like,
yes, I did. I was resolving that problem in the last 2 weeks, and I found out that was like numerical and algebra problem, and I modified my algorithm, and I add some like nan check and like add some checkers, and that was resolved.
Oh yeah, okay, I see. Yeah, kind of was where I was also, of course, doing like maybe even the last 2 weeks, right? So also on my side, it took pretty long. I was also revising the algorithm. I didn't find any bug there. And, you know, after that, I was just wondering what the hell is going on, if the algorithm is correct and like all the values are being assigned, all the null checks are being done and stuff like that. Why it's going wrong? And then I found out that it's actually not a numerical algebra issue on my side, but rather this rendering issue. Yeah.
Okay. Let's see.
Yeah, but thank you anyways. Yeah, thanks for the idea. I've checked on that.
Good luck. All right. I'm gonna share my screen.
Okay.
Yeah. Okay. So probably I can show my. Is it?
Let me see. Yes. Yeah.
Okay. Let's turn my simulation for that. So as you can see over there, this panel is like the white lines are is like the stimulus received. So so for here from O0 to O7, that is the attributes for the O faction, and for G0 to G3, that is the attributes for the values for taste. And the red line is the predicted taste. So for here, that's the preference. So now, and that is also a problem for simulation. That is the Braitenberg vehicle is like to stick with a stimuli if something like this happens. So if it's leaving the stimulus, the preference is like going down. So it's going to go back, and when going back, there's like no increase in the preference. So as you can see, then it's just like to leave and then go back to leave and go back to leave. So that is one problem I currently have, and that is just like for debugging. That is output of O factory bulb. So it's like an internal state of the neuron of the O faction neurons. You can see now it's just like doing this again, and that is also associated memory reach matrix. So as you can see, I made it like a heat map, and also that problem is probably a sec fault. So now it's stopped. That is due to some sort of problem that I think it's due to the package problem, because it's saying that in the website of PyQt graph, it's saying that it is not a very developed library. So it is saying that it is not as developed as Matplotlib or any other things. So probably that's caused that fault. And maybe that's due to my C kernel codes for my Python, my Python code. So I wrote some sort of computational heavy parts in C, and I use Python, and I use BLAS functions. That is like the base function for NumPy, and they are all implemented in C, and probably some parts are in Fortran for. So this part might also cause sec faults. So these two are two problems of my current simulation.
But I mean, it looks pretty good. I mean, can you run it again? I have some questions about the heat map. So the heat map is associative matrix or how are you measuring them?
Oh yeah, so for the vertical axis, that is the inputs of this. So the outputs of olfactory bulb is fed into the associated memory. So for here, that is for vertical axis, that is yeah. Let me say it like this. So say this one is the connection between the zeroth olfactory interneuron and the zeroth gustatory interneuron.
Oh, okay.
Yeah. So that is between the zeroth olfactory interneuron and the third gustatory interneuron. So for this block.
So it's like two different classes of interneuron that are like they're combining or they're intersecting in some way.
Yeah.
Okay. Oh, that's nice. I like it.
And also, as you can see here, it is struggling.
Yeah.
The
In
purpose
real
is
time,
changing.
it probably is. Is there a way to output the data, like just to run the environment and then to like output each of these graphs as like a CSV file? Because you might actually be able to run it more smoothly. You might have an option for that, where you can run it more smoothly, and then plot the data out later using the same sort of thing. I mean, you can plot it out. You don't have to plot it out in real time. It could be that the real time aspect is something going. There's something going on with that there too.
So, do you say that Do you say that noting down the historical data is helpful for those struggling behaviors like this?
Yeah, I think if you have an option, where you can just instead of having the visualizations real time in the plot here, to just have the environment and then to have all of the data collected and then exported after the run in a CSV file. So it could be like, you could run it 10 times as long as this, and then have each of these windows where you have the values in numbers and in text delimited format, so people can then pull them into like Python offline and make the same plots. But you would be able to then get all of your data. You could even do it by time slice if you want, but it would be people could play with the data more, but it would also be maybe more stable.
I see. Yeah, that's a good idea. So currently I'm using multi-threading for real-time plotting, and that is it.
Yeah.
Data is good.
I mean, this is a good option to have if you want to, like, if someone wants to run it like this. I like having the option to do this because, you can actually see the thing in real time. It's definitely useful, but you also want to have the other option too.
Excuse me. So,
Ziyi, are you still there?
yeah, sorry, my mom is full. Yeah.
Oh, okay. There you go. Okay, so that's good. Thank you for that update. Now, both Ziyi and Stefan, did you take a look at Ankit's proposal or his presentation that he gave last week?
Yes, I did. I took a look at the recording.
How about Stefan? Did you?
Yeah, I did take a look at the proposal, but not the presentation yet.
Okay.
Didn't have time for that.
Well, why don't Ziyi can start. Do you have suggestions for Ankit?
Actually, I have some questions. So, firstly, what is like the differences between Explorer, Lover, and Brasive say prototype, because I'm saying they are all approaching the stimuli.
Okay, so actually, if you see the book, there are in each of the vehicles, they have categorized the vehicle into two groups. One is like vehicle 2A is cowardly and explorer. No, cowardly and aggressive maybe. So what happens is, if you see, each time the vehicle is not approaching the stimulus, if it is case 2A, which is vehicle 2A, in that case, vehicle is actually going away from the stimulus, which is like it is fearful of the stimulus, so it is going away from that. And secondly, about the prototype thing, that was just to show to the people what my idea was about. So like I have a single stimuli and single vehicle, but in future, as I'll continue with this project, I will make the system more complex, like more vehicles, more stimulus, and a lot of other changes that I proposed. If you see my presentation last week. Yeah.
Okay, thanks. Also for labeling, I don't know, what is it like to label the different kinds of stimuli?
Yeah. So what I felt like, if we have, I have already pointed out that I'm proposing to have multiple stimuli in the environment just like you had. So what I feel like is introducing different type of stimulus, just like if we can't realize it in a 3D space or in a real world situation, what I'm thinking is to in the 2D screen itself, I have at different locations I have some JPG, some image file and some sound file which is there at different randomized locations. So actually labeling the stimulus and actually making the stimulus work as if it is a real world situation, and the vehicle is actually behaving due to the stimulus that are present in the environment. I hope that is clear.
So like, what are the labels like? Are they just like single values or like vectors or matrix?
No, the labels will be like, if there are images, there are lots of images. There will be. I'll do deep learning training of the images itself, and based on the result, we will just label that stimulus as aggression provoking or coordinates provoking, or the labels are yet to be discussed with everyone. So I'm just in the very starting phase of my project. I had my idea, I had put forward to everyone, and just trying to make that complicated enough so that it looks good.
Okay, thanks. So maybe as a Python user, I can just recommending some sort of packages like PyQt and PyQt I think they are better for visualization than like Matplotlib or maybe any.
Yeah. So before that, I was interested in just setting up the environment on a better platform. Like currently, I'm using Turtle, and it doesn't provide that smoother simulation of the thing. So I was hoping if you guys know any other Python library, because I want to stick with Python because I have to do the deep learning training in the later part of the project. So do you guys know any other environment that Python provides for user interface? Yeah.
Okay. Thanks.
Yeah.
No, yeah. What's been said is good.
Yeah. But Stefan, do you have any comments for Ankit?
I will think about it and maybe tell Ankit if you have any.
Yeah, no problem. Yeah, so that's good. Let's let's go to the board actually. Let's see. And I think we've had a lot of good conversation today, a lot of things to think about, and a lot of demos. And so this is the link to the repository, and I'll share my screen here. So we have back to my, okay. All right. If you go to the repository, you go to projects, you go to that tab, the group meetings review board, and now we have in progress and to do. So we have a bunch of in progress. Let's go from the top. Assemble neuroethology resources for Jesse. I sent Jesse, I think I sent him some good resources.
Yeah, like 5 papers or so. Thank you.
Yeah, you're welcome. So I'll put that in done. Check Stefan's Trello board. I checked that last night. Is there anything you want me to know about that, Stefan?
I'm sorry?
About your Trello board. Is there anything new you'd like me to know about it or draw my attention to something?
Not really, no.
Okay. Create a list of data export and persistent saved attributes. So this is the thing that we were just talking about with Ziyi, where you create a CSV output of your data that come out of the simulation. So again, it's just a matter of getting a bunch of parameters, outputting them, and then allowing the user to play with them as they might want. Let's see. Number 22, defining fitness function in the context of behavior. So this is actually something Stefan mentioned just today. So you're going to work on a little bit more on the fitness function, you said?
Yeah, I do.
All right. Number 25, create a list of visualization tools and solutions. That, again, that link is, I think I have that. I don't know if I have that link in here. But it's in the repo. It's in the README in the main repo here of GSOC Braitenberg Vehicles. If you go there and you go to the README. And you're free to add anything in here. If you know of a new tool that you see, or there's a new blog post about how to use a visualization tool, you can put it in that README. And then there's another one. This is for Jesse. Research agent mapping, perception, and representation of environmental space and or resources.
I guess that's still in progress.
Okay. Then number 24, find conference funding through professional organization. We are, this is Stefan and I, okay, let's update that. Send funding justification, travel grant, and Stefan and I talked about that. That's where the INCF is giving out their travel grant. So we have to make a case for that. Present a paper. That was Jesse. You just did that. Congratulations. And that will go in finished. Done. And Ankit, you're welcome. If you want to present a paper to the group, you're welcome to do so. Papers are something that you're interested in reading more about. So you just, you let me know what the paper is. You put it in the Slack channel, and then people can read it the week before. And then you would prepare like a 15 to 20 minute PowerPoint presentation on it.
Okay, so fine.
Okay. Oh, you said something?
No, I'm fine. I was just concerned with starting the environment and looking for a better environment. So
okay, yeah.
Once I'm done with that, I'll just get started with my work.
Yeah, that's fine. Okay, then number 37, actually set up GitHub project materials. That's Jesse, I think. In Ankit.
That is in progress.
Okay. And Ankit's in progress there too. So, deep dive into every good regulator theorem, number 36. That's, I think, Jesse.
Yeah, also in progress. I guess I was still gonna meet. Was it Tuesday or Monday? I don't remember.
Well, we still have. I think we have to make that determination. We were busy last week, so that was. We had to reschedule, but I'll keep you in the loop on the rescheduling.
Okay.
Okay, and then number 21, discuss relevant scientific questions. That's in progress, and we've made some good progress on that today. Share resources and implementation ideas. That's in progress. Find dataset references for GitHub repository. So again, those are in the repository under datasets. If you want to look at data for like connectomes, we have things in that repository. Develop way to evaluate movement to cues generated by network. I think that was Ziyi. So, have you thought about that more, Ziyi?
Actually, I am getting more and more confused. Yeah, after I uploaded my visualization.
So,
do you have suggestions?
So, develop ways to evaluate movement. Well, I think, like, Stefan's method for, like, using that as a fitness function is a good way to, like, approach that. I don't know, like, because you're looking at it a little bit differently, I don't know if that's the best way to do it. Another way to do it is to look at, like, the error. So if your agent moves towards a cue and it's, maybe takes a circuitous path or it's off by a certain number of degrees, you could use that as a criterion as well. I guess I'd have to look at it a little bit more closely to know, like, what the what the best solution would be. But maybe if you you can put some ideas in the Slack channel, or maybe like some screenshots to show like how it, where you're confused. Because if you get some specific points, maybe we can address them.
Okay.
Okay. Yeah. So it might be a little bit, might be actually pretty simple. It might be a little bit more difficult. So why don't we plan to do that? Just take some screenshots and put it in the Slack channel, maybe with some description, and I can look at it.
Okay.
So we move on to the to-do list. Develop use cases and deploy. We're kind of that's in progress. We discussed this with Stefan, and that's part of what he's going to be doing in the next couple weeks. Respond to request for travel funding. That's in progress. That was what we just discussed with Stefan. Elicit feedback from Stefan and Ziyi on Ankit's presentation. That's done. We just talked about that. Although if you have more comments for Ankit, he'd be welcome to take them because, more input's always useful than less, I think. And then these last two, 29 and 11, these are kind of old issues, and we'll leave them in to do. Before we go, does anyone have any other issues that they want to put on the board or bring up?
I might put something on there about the every good regulator thing, but I'll probably talk to you about that on Slack and put it up there, but not in the moment right now.
Okay, that's fine. Anyone else have any other issues?
It's fine on me.
Okay. Ziyi and Ankit?
It's fine.
Not now for me.
Okay.
No current.
Okay.
Yeah. And G was confused about all the vehicles getting into the same direction. If you see the YouTube video of the last meeting, I have shown my presentation in which the vehicle is, if it is behaving covertly, it is getting away. So just have a look, or you can just run the code on my GitHub repository. So you should be clear with that. Yeah.
You might share the, I don't know, you might share the link to Ziyi if there's, yeah, in the repository. So.
Yeah.
Okay.
Sorry, can say that again?
I asked them to share the link for the repository with you because.
Okay.
It's actually already shared in the Slack channel.
Oh, okay. All right, thanks.
Thanks.
Okay, so thanks for attending, and it was a good meeting, and see you next week. We might have to reschedule that because I'm traveling on Saturday, so I'll mention that in the newsletter. So thanks for attending, and talk to you guys later.
Okay.
Thank you. Have a nice week.
You too.
Take care, everybody.
Bye.
See you guys.